going on in Pasadena. So for any Eastsiders out there, please come join us. And if you want any more information about cross campus or anything we're doing, come see me or Chris or Rudy. We're all wandering around. And thanks for being here, and thank you, Subhash, for continuing to have some really great events. Enjoy, everyone.
Thanks, Becky. So I just want to do a quick introduction for Chris. Chris is currently at Databricks. Prior to that, he has worked in several established places like Netflix. He's also going to talk about Netflix and give us a few examples of how they're using Spark. And Chris is also mentioned he's planning to move to Los Angeles. So we need to make sure he follows his work. Like this?
Just moved to San Francisco, so I'm tired of moving.
Okay. So let's give a warm hand or a warm applause for Chris, please.
Thanks a lot.
By the way, we have books and t-shirts to give away, and Chris has said if you want to get any of those, you need to answer questions. He's going to ask or pay attention to his talk. Yeah, this is going to be a quiz.
I've got about 6 questions, so yeah, pay attention, please, and then you can get your shirts and books and that kind of thing. Yeah, my name is Chris Fregly. The topic today, I've been kind of having fun with this a little bit. It's called Spark After Dark. I'll explain in a little bit. I think the description, Subhash's description, kind of like mentioned a little bit. But yeah, first of all, thanks for having me down here. Yes, I live in the San Francisco tech bubble, and I don't get to get out too much. And yeah, there's so much going on down here. Riot Games, and yes, eHarmony. Yeah, there's a lot of stuff going on. So yeah, I'm actually going to be seeing some of those companies this week. So yeah, pretty excited to meet you guys, and yeah, please come up and yeah, let's chat. So this is a 2.5-hour talk that I'm going to smash down into 45 minutes. I might try to get an extra 15 minutes out of it. Yeah, better start talking quick. Yeah, so as Subhash mentioned, Netflix, and then Spark contributor. I worked on the Kinesis Spark streaming integration, which was kind of fun. I needed it for a project and realized that it didn't exist, so I took that opportunity to contribute. I'm working on a couple Spark books. Those are right now kind of slow because I just joined Databricks, the guys behind Spark, and they're working my ass off. So, yeah, so I'm going to show the Databricks. This is not a sales pitch by any means. This talk, yes, I've been doing this talk and slowly building it up for like the last 8 months. Since I joined Databricks, I have access to Databricks Cloud, which is the little IDE notebook, kind of like Python notebook, Scala notebook. But yeah, that's going to be the last thing you'll hear me talk about that part of it, except for the demos. There's the Kinesis thing. I just want to get like this was like 4 bullet points, sounds like 100, but just kind of high level. Who here is familiar with Hive and Pig and Hadoop infrastructure? Yeah, MapReduce, that kind of thing. Okay, good. So you probably wouldn't be here otherwise. How about Parquet specifically? Yeah, Parquet file format. Good. Okay. Yeah, because we're going to talk about that. There's a demo with that. How about Storm? Like Kafka, Kinesis. Yeah, you guys use? Okay, good. See, we'll skip the Amazon stuff. That's pretty much given. How about Lambda Architecture? You guys interested in hearing about that? Because I'm trying to figure out what I should be presenting on too. So, and yeah, I'm going to post all these slides. This is all public stuff, so you guys can go through it. It's like 114 slides, but we're going to go like 5. Yeah, there you go. Yeah, increments of 5. How about machine learning? Yeah, anyone like classification? Okay, yeah. So I'll spend a little time on that. Yeah, PageRank. Yeah, how about things like Bloom filters, count, min, sketch, that kind of stuff? You guys interested in approximations? I mean, the people who raise their hand about streaming should probably be interested in that, because as things scale out, you really have to start to approximate sampling, hashing, that kind of thing. Quick overview, boom, basically all the same stuff in this app. So there's going to be about 5 demos if we have time for them. Yeah, otherwise, all the code for the demos is out on GitHub. I'll share that link later. Quick Spark overview. There's this paper called Dryad. Has anyone heard of this paper? Yeah, it came out of Microsoft. I started studying Spark and realized Microsoft had something to do with this. I wanted to hate it, but yeah, so I read the paper. It was awesome. And yeah, there's a lot of principles. They chose Scala for Spark. I'll explain that like in a little bit, but like why they chose that. It was partially because this came out of Berkeley. It was an academic language. Also because of the Java support, right? Like runs the JVM. Most of the big data projects are in Java, right? I mean, straight from like Lucene all the way up, to MapReduce and yeah, things like that. So the big misnomer about Spark, people always talk about what happens if my data set doesn't fit in memory, right? Everyone thinks of Spark as an in-memory engine, and that's totally not true. In fact, you'll see 2 to 10 times faster than MapReduce without any caching turned on. So obviously, when you turn caching on, yeah, you get like 100 times speed up. And yes, I don't like spewing benchmark numbers because they change all the time and they're skewed and all kinds of stuff. But the key point here is that you don't need memory to like really get the benefits out of this. It's still going to be faster. And, yeah, we'll talk about some of the pipelining and some of the optimizations with the execution engine. So here in a bit. Yes, like I mentioned, it's compatible with Hadoop, all your SERDES, all your UDFs, user-defined functions, like SERDES, serializer, deserializer. Quick timeline. So yeah, I mean back to 2002, MapReduce, Google, some guys over at Yahoo, 2006 created, like Cutting, I believe those guys created like Hadoop, which was the open source version of the Google paper on MapReduce. 2007, Dryad came out. The first Hadoop summit was 2008. 2009, there were a few students in the Berkeley Amp Lab that had read the paper. They were there to do a lot of machine learning and graph processing, and they realized MapReduce just wasn't, it just wasn't cutting it. There was just too many synchronization points, too much data going between disks, not enough pipelining, not enough intelligent ways to combine these operations and do more things in memory and stay off the disk. 2010, first AmpLab paper. There was a second one came out about 2012. They started talking about some of the streaming aspects of it. First Spark Summit was 2015. I think I missed it. I went to the second one, but and then this year, or it was early last year, 2014. Spark became a top-level Apache project. I'm pretty proud of that little hitting symbol over there for the AMP Lab. That's the Berkeley. So the AMP Lab stands for Algorithms, Machines, and People. I believe it started in like 2008, 2009. And the goal was to try to merge these things, right? So obviously a lot of machine learning, like ways to help data scientists and data engineers really pull value out of data. This is the Berkeley Data Analytics Stack. It's often referred to as BADAS, which I love. Like this is like the biggest screen. It's not normally this big. This is kind of the Spark core, the execution model, and then these are the higher level libraries. This is one reason I liked Spark when I first started reading about it and studying it, is that I could pull down one set of libraries. So think back in the old Java days, right? Like you would pull down the JDK, but you also got a whole ton of libraries on top of it. You got your networking libraries, you got applets or whatever, right? So here it is. This is Spark SQL. It's the batch processing that's querying. BlinkDB, we're going to talk about a little bit for approximations and getting answers back quickly when you don't need the exact answer. Spark streaming, pretty obvious. The MLlib, that's the machine learning. I think Spark R is about to come out with a sort of early release, so that's the ability to actually run R on your Spark cluster, so it's the first time to see distributed R. And then GraphX, that's for connected components and PageRank and all the fun stuff. You guys have probably heard of Yarn, of course, right? Out of the box, these guys wanted to support Yarn because they know that people have installations out there. There's no way that Spark standalone and Mesos came out of the AMP Lab, but they realized they can't push a cluster like Resource Manager down people's throats. They already have Yarn, so they support that, of course. There's some of the data sources that they support. That Spark supports, so Cassandra. The data, so we work closely with the data stacks guys to create Cassandra connectors, of course, Elasticsearch, DynamoDB. I'm actually working on that right now. HDFS, and we'll talk about Tachyon. If you think of Tachyon, it's kind of like the old RAM disk, that you installed in your Apple IIb like 20 years ago or whatever. Just basically off-heap storage, right? And it's all written in C, and it's super optimized to do its own memory management. So the whole goal there is to pull things out of the JVM so that you're not crashing GC, right? So we'll talk about that a little bit. Okay, The goal, the point of this slide, I'm going to try to summarize some of the things here, but basically this is one of the other advantages when you have a unified library set, right? So any kind of optimizations that are done in the Spark core, they'll automatically get picked up by the higher level libraries. But what's really interesting about the Spark ecosystem is that things that are fixed in MLlib, for example, the machine learning library, get pushed down in the core. So this happened quite a bit with Spark streaming. There was a lot of GC improvements, memory management, cleanup. The Spark streaming is a long-lived process. And so a lot of that got pushed to the Spark core and got picked up by all the other projects. So there's this project called Shark. It's been deprecated. It was basically like a way to get Hive queries to run on Spark. It's being replaced, or it has been replaced by Spark SQL. There's a project called Spork too, which is one of my favorite names. It's Pig on Spark. There's a collaboration with Twitter and this company, Sigmoid Analytics. Twitter, huge Pig users. They want to use Spark. They needed some way to get them to work together. So Part K, that was a collaboration between Twitter and Cloudera for the Impala project. What's kind of interesting about Cloudera, I realize I'm actually wearing a Cloudera shirt right now, but they tend to push Impala, right? That's their product. So they do include Spark SQL with their like CDH, but I can't really hear too much about it. So here's some Spark use cases. I've noticed a lot of people ask this question, and I guess I'm surrounded by it so much that it actually took me some time to sit down and think about it. But the big one is being able to sort of analyze your data quickly, right? Like ad hoc, or analytics, being able to kind of poke around, not relying on your BI folks to give you reports and that kind of thing. Still does the traditional ETL, and of course Spark streaming plus MLlib. This is kind of interesting. You can do some fun stuff when you're building models in real time. So at Netflix, for example, and we didn't do this, but because it was about 4 years ago when I was there, but they're starting to do some of this now where you can actually keep an eye on network traffic and which CDNs are performing, and you can actually shift traffic based on that. So what we would see a lot is that the Apple TV, for example, had problems with limelight, but we had no idea why. So it didn't really matter. We just wanted to shift up and go to Columnar or whatever. So until things got better. So building models every minute, every 10 minutes, that kind of thing. So GraphX. So this would give you things like people you may know. You see that a lot on LinkedIn, and it probably gets a little annoying when your ex-girlfriend shows up and has no idea why that is. But, and then of course Lambda Architecture, which we'll talk about a little bit. So yes, I like this slide. Kind of shows MapReduce. This is 2002, 2006, or whatever, and then just wasn't flexible enough, right? We needed stream processing. We needed, a faster execution model. So this huge explosion of technologies came out, and then things kind of get simplified down in Spark, right? So people will naturally ask, why do I want to use one tool for all these different things? And there's some truth to that GraphLab actually outperforms GraphX in certain cases and things like that. So we're not claiming to be the best in all these areas. Things are always getting better, but it's nice to have a unified API, right? Okay, this is the core abstraction. It's the resilient distributed data set. If you ever come to interview with Databricks, they're going to ask you everything about this stuff. This is the most important concept here. Basically, it's what keeps track of where all your data is. So these huge data sets, they're spread all around the cluster, and just knowing which ones are in memory, which ones are on disk. So this is a sort of visualization here of this particular partition of the data set is in memory. That one's in the HDFS data node, and things will flip back and forth depending on the available resources for each of these worker nodes, right? So things get evicted in LRU fashion. there's this concept, there's this concept of a lineage. So as things get transformed, as you do maps and filters and start to like massage your data, it's keeping track of what transformations are happening at each point, so that you're not actually like creating. It's sort of a lazy evaluation thing if you guys have used Pig or SQL, for example, right? I mean, it has like the logical query plans and physical query plans and that kind of thing. So that's one thing I've noticed actually. I spent my whole career trying to avoid SQL and data stuff, and it's coming back. I was a big Java guy, big Scala guy, and now it's like I have to get involved with data. But it's actually fun. It's because it's fun from just trying to yes, I saw this at Netflix where there was so much data, and like I didn't understand how we're going to use it all. And just talking to those data scientists, those guys were they track everything, by the way. Everything that you hover over, anything you kind of click, but they go back, all that stuff's tracked and it's fed into recommendations. So this is the RDD interface. There's 5 main methods for an RDD. This is how you define the partitions. This is your dependencies for the lineage that I mentioned. This is how you compute for that partition. So the easiest example would be like Hadoop, like RDD, and it's not really computing anything. It's just loading it off disk. So that would be so I'm going to talk about 4 or 5 different RDDs here in a second. You can define a custom partitioner. So that comes in handy with. So for example, so if you know your data set, right? So you understand, right? It's a range or what particular keys, like hash keys and that kind of thing. So you wouldn't normally be like writing these things, but if you do want to get down, I know a company Esri. Anyone here from Esri? So they actually built a geo like RDD, and they were doing a lot of this, to basically partition by neighborhoods, right, like neighboring places on the map and that kind of stuff. Preferred locations, that's for data locality. This comes up a lot, like you want to be on the node that actually has your data, right? So HDFS, if you have 3 like replicas of each partition, it's going to try to find nodes that actually have that data to keep the data local so it's not going across the network. So that's actually out of the code base. I use Eclipse. I think I'm the only Spark person that uses Eclipse. Everyone uses like IntelliJ, but I'm pretty happy with it. So there's Hadoop and there's pair RDDs and there's JDBC RDD. These are for the GraphX stuff, Vertex, Edge. This is the Cassandra one I mentioned. That's the Esri one, and that's the Elastic Spark. So there's tons of these being developed, but they all implement that same interface, the same 5 methods. So just real quick, the compute, like I said, is just read it off the HDFS block. There's really no dependencies on it's just basically the file location. But as you start to do things, so this is a transformation. I'm filtering my data set. I just want ages over 25 or whatever. This gets maintained, and then if a node dies, then you can actually rebuild it with just that one partition, right? So it'll go back to disk and just build that one partition. That's kind of how that works. This is a somewhat complex one because we're joining, so it actually has 2 sets of parents. It's got 1 pair of parents. So this is kind of just trying to take like a physical text file, huge set of records. They get partitioned out into 3 nodes. Some stay in memory, some get flushed back to disk, and then logically it's one Hadoop RDD with 3 partitions. And those partitions are chosen by the partitioner, which would be hash partitioner, for example. So filter, it's the same thing. The partitions, it's going to keep the same ones as its parent. Its dependency is the parent. The compute is the filter predicate, right? So anything over 25 like years of age. the joined RDB, the big thing here is that if it has to rebuild, it basically has to rebuild off those two parents, right? So it's not just a linear straight up. Yeah, it will actually have to calculate each parents and then go back down and then read. Yeah, this is all failure stuff. This is all if the node dies kind of thing, and then sort of intermingling in here. Yeah, so DAGs are the basis of this, right? Like, yeah, Pig uses these, SQL uses these, and yeah, everything's big AST, right? So, what's interesting, I should probably mention, yes, I have it right here, is that transformations are actually lazy, right? So, what we can do is actually optimize certain things. So, instead of going through the entire data set here, and then going through the entire data set again here, Spark actually collapses those two functions, right? So you just scan the data once, and you're going to filter and map at the exact same time. So it's an ON operation versus O2N. And then, yeah, not until you actually do an action, then this gets executed, right? Yeah, then it gets all pipelined together, and yeah, the data is saved out. So here's an example. There's this to_debug string. Kind of shows you the lineage there. That shows you all the partitions. And I don't have an example of a joined one here, but yeah, you would see two parents. Okay, so this is a pretty simple demo. I might just skip this one and maybe do it later, but I want to show some that get into some more depth here. Join, that's pretty. Yeah, join optimizations. If you guys are familiar with the Hadoop distributed cache concept, where you can actually store smaller tables in distributed cache that's shared by all the nodes. Yeah, that's essentially what this broadcast mechanism is. So if you have like a gender table, for example, and you have that's relatively small compared to the huge set of users, then you can just broadcast that out once to every worker versus shuffling everything across the network. Core Spark API. This is an interesting quote I picked up from somewhere, like Meetup or something, but someone called it distributed Scala collection. So, oh yeah, how many people are familiar with Scala? Okay. Yeah, do you guys like it? Yeah, like looking at Java code. Man, I couldn't do it. Yeah, so there's pretty much native support. I've got an asterisk. Scala is always the first one to come out with Spark just because it was written in Spark. And we kind of rely on a couple people in our office that do Python and the community, of course, right? But I think we're pretty much at par right now with all the different languages and all the different libraries. R is coming soon. I'm super excited about that. Let's see.
Any idea when R will come out?
There's a company, Alteryx, that's working on it. Alteryx, I believe. And who else? It should be, I just heard in the office, I think it'll probably be by Strata. I think that's going to be their big announcement, which is next week, right? So, yeah, there's going to be a lot of big announcements next week. It's not, from what I heard, it's not like totally production ready. It's just more of a kind of release kind of thing.
Is Python equivalent to Scala now, or are there big features?
Yeah, I think the only library that's still behind a little bit is the GraphX library. I think MLlib is pretty much up. Yeah, no, MLlib isn't, because they added the pipeline stuff. Yeah, I see. Someone shaking their head is like, yeah, no, you're full of shit. We're smart enough to know that we're not going to push Scala down data scientists' throats. We have to support Python and R, of course. So, yeah. So why Scala? I kind of mentioned this before. I mean, these are, all the libraries I could think of just, sitting here and starting to get a little crazy, but yeah, these are all Java-based. And yeah, again, we knew that we couldn't just impose Scala on people and completely ignore all their Java-based UDFs and MapReduce code. So yeah, their combiners, reducers, that kind of thing. Supports closure, so yeah, this is nice. We can ship the code to the data, versus kind of converting it. It's functional, but it's not completely obscure like Pascal. Yeah, it's typed too. This is a huge debate. Yeah, who here is pro type languages? Wow, people are scared. Wow. I'm a huge type guy. I don't know. I've written Ruby and I always get myself in trouble. And, Python drives me nuts, but that's a personal thing. There's a Spark REPL too, or like Scala REPL, right? So Spark uses the Scala REPL. And plus it's cool. Yeah, why wouldn't we want to use Scala? It's good for the resume. So yeah, this is a list of transformations. I'm not going to spend too much time here, but think of these again as being like lazily evaluated, right? So you've got your union, you've got your filters, maps. This stuff isn't actually happening when you write it in the code, not until you actually do an action. And where it can look at the entire scheme and then optimize from there. So these are actions. I think the ones I showed before were, say this text file, say this Hadoop file. First is, just give me the first one. That's for like debugging and that kind of thing. Collect, pulls everything down. This is a scary one. If you guys have done any Spark programming, you can really get yourself in trouble because it's basically pulling from the entire cluster all your data down to the driver, to the name, that one node that's actually running your application that's spawning all these jobs. So, be careful with that one. So these are pretty familiar phrases here, terms, jobs, contain many stages, stages contain many tasks. By default, Spark tries to use as many resources as possible. So CPU, memory, that kind of thing. You can kind of segment it out using these scheduler pools, defining priorities, separating out users, and it's going to be FIFO within the pool, but if you guys are familiar with the Hadoop Fair scheduler, that's basically what they implemented. Let's see. The whole key here, right, is just trying to stay off disk. If you do need to go to disk, scan it once. Obviously random is bad. You want to seek once and then just tear through the data. Parallel execution, task pipelining. This is what I was talking about, where you can combine the map and the filter so that it's just one pass through the data. And it does fancy stuff. It actually combines the code and uses Scala reflection and some fancy stuff there. This is important too, data locality. If, obviously, you want data that's in process, that's in your JVM, that your code, it doesn't need to go to disk, doesn't need to go to the network, anything. The next best is it's the same worker node, but it's going to go to local disk and not across the network. Then there's rack, which you can define your network topology so that it'll stay within the same rack versus hopping through switches and that kind of thing. And then any. What you would do here is basically put timeouts and say, find me a JVM that is processed but within 200 milliseconds or something. If not, then start hopping off the chain. Fault tolerance uses those lineage graphs I was talking about. So if a particular worker node dies, it's just going to rebuild that one partition. This is the craziest slide I've ever built here, but it's pretty badass, I guess. All right, so this is bad. Shuffle is bad. Single ones are good. This is the pipelining I was talking about, where it can combine these into one physical function. Stages are defined by shuffle boundaries. That's the best way to think of this. So things can be pipelined up until you have to shuffle. Then you can't pipeline anymore because you don't have the data. You have to get it from all the other nodes. So there's a special case here where if you have already partitioned your data, it's smart enough to know that this guy and this guy are actually physically on the same node, so it doesn't have to do a shuffle. So those can get pipelined. Pipelining stuff. Yeah, have you guys heard of this? Yeah, anyone heard of the Daytona Gray Sort? Yeah, I thought this was like a NASCAR thing when I first heard about it, and I dug in. Yeah, there's a pretty recent blog post. Some of my coworkers. Yeah, so this was the old record MapReduce. So basically, what you do is you take 100 terabytes of like unsorted data. I think it's 10 bytes or something like that each record, and you have to sort as fast as you can, as many like nodes as you need. So yeah, as you see, there were 2,100 nodes. Is there a date? I forgot to put the date. Yeah, so that's 2,100 servers, and it did 72 minutes. Check out the throughput too. This is I'm standing right in front of it. Yeah, 1.42 terabytes per minute versus 4.27. That last column, yeah, we went crazy and did petabytes just to see what would happen. But the actual contest itself was the 100 terabytes. What was cool is that these are 206. Yeah, these were EC2 nodes. These were Amazon nodes. I somehow stumbled upon our Amazon bill. And, yeah, that was not a good month. I think Amazon gave us a little deal too, hopefully. Yeah, because we ran it like 20 times, right? So, yeah, so it was 23 minutes versus 72 minutes. They did some of these optimizations. I'm not going to go into them. Essentially, just trying to control resources, trying to keep your open files down within Linux, yeah, using epoll, yeah, using zero copies so that you're not going through user space, back down kernel space, that kind of thing. The key here is that we're able to finally saturate the network. So yeah, 1 gig Ethernet, approximately, that's sort of theoretical, but we're finally able to yeah, saturate the network between the nodes. Whereas the old, right, because so for these big data systems, everything is about how fast you can shuffle, how fast you can sort, and yeah, so we're finally able to make the network the limit instead of our code. Yeah, zero copy epoll. Yeah, it was yeah, so we implemented menu. It was the first time some of our Scala people had to do Java code, so it was kind of funny. But yeah, actually worked out really well, and they still hate Java. Implemented yeah, Tim sort versus the old. Actually, yeah, I meant to look this up. The Java sort method, that became Tim sort, didn't it? Yeah, does anyone know, like in 1.7 or 1.8? Because I thought it was an old version of merge sort when they changed it to Tim sort. Okay. This is fairly new, the ability to scale up and scale down. This is something we did quite a bit at Netflix, and when we first talked to Netflix about Spark, they were like, hey, yeah, we need to be able to auto-scale, right? Yeah, they're big Amazon users, obviously, so that used to cause problems. Now we support it. Actually, that work was related to some of this work as well, this new network module. So we're actually able to tear down Spark nodes, but continue to serve up data sort of off heap. I can talk to you guys more about that after. Okay. The big thing here is Spark standalone. This is to get people up and running quickly, but there's actually quite a few people using it in production. People, yeah, some of the larger companies like Netflix, like Twitter, those kind of guys, they like to use Mesos because you can sort of have a hybrid. So like you can have Hive running alongside Spark, running alongside Cascade. Spark standalone is just Spark. Yeah, how am I doing on time? Good. 30, okay. I have 30 minutes, or 28 minutes left. This is a typical deployment. This is what I was saying, the driver, when you call collect, all of these nodes then pull the data down. So that's potentially bad. I mean, A, it's going to take a long time. Yeah, we see a lot of these at Databricks. People ask, hey, why is my collect taking so long? I didn't realize this is what it was doing. Yeah, this thing usually OLMs. We just put a max limit in so that you know what OLM. But yeah, so you can use Zookeeper. We actually don't see that too much. We don't see people worried about the HA, which scares me. But, yeah, so that's, yeah, there's your cache, there's the executive JVMs. You want to co-locate, obviously, with HDFS, your data nodes, because that means that you're at least node local at that point. Let's skip the R, I'll skip. Okay. Yeah, there are some Hive people out there, right? So some of this stuff should look familiar. Support all the joins, all the typical stuff. Any kind of Hive UDF that you have. I think there's a bug right now with a timestamp, but I think that's getting fixed. Anyway, so Hive is what Spark SQL uses underneath the covers. It's the syntax is Hive QL, but the actual execution engine is all rewritten. The problem was Shark, that I mentioned before, actually used Hive underneath the covers, but it sort of limited us in some of the optimizations that we can make. Yeah, so some of you guys might know that there's the Hive Columnar storage format. So you flip the data. If you're doing, and we'll talk about this with Parquet also, but if you're doing a lot of aggregations, summing, average, that kind of thing, right? Like you want all the column in your data, you want all the values for that column to be next to each other on the disk, because you want to seek once and then just rip through and do your sums versus typical like relational database where you're skipping rows, skipping just to get that data. I mean, it's physically on the disk, you have to jump around. So if you flip the model and store it so that all the column values are next to each other, it's huge difference. So this is right out of a Twitter blog post. Parquet was developed, like I said, by Twitter and Cloudera. They do a lot of compression, a lot of, you probably remember this stuff from college and from your interviews and things. The run length encoding, dictionary encoding, bit packing. The problem here is that you need all the data, or else you can't really make these optimizations, right? So so Parquet is better for data at rest, not necessarily for doing inserts and updates, right? Because you basically have to re-encode the entire thing. Also, too, it's not good if you're trying to select all your rows, because it stores all the columns together. So you're kind of flipping it back to that. Yeah, that would almost be better back to the traditional row-based way. Also, because of the compression, this chart here is showing, there's about a 30% savings. So, this is huge for Twitter. They have, tons and tons of data, and they're able to save on their S3 costs or whatever they use, right? Parquet, I can show this one. So I just ran it, and I know it works. So this is the Databricks cloud product, like I mentioned before. Notebooks, you've got the cells, that kind of thing. It's fun to train people in this tool because it's just so quick. You can just copy and paste things. But you guys see that? So anyway, we've mounted something. So this is all S3 based. This is all Amazon based right now. The product is, but we're pulling in some ratings data. This is going to be the dating site ratings data. We're going to create some. So here, I actually hack it. It starts off with CSV and then create JSON, just so I can show you guys how to create an RDB from JSON. It's going to dynamically infer the schema. So if you have mixed data in your JSON, it's going to do an aggregate, right? And it'll just put blanks for anything that's not there. So that's kind of cool. Here we're just going to register a temp table. That's an in-memory table because we know that we're going to do some aggregations on it. And here we're mixing Scala and SQL and let's see. I guess this didn't work. Oop, I'm actually in the wrong one. Oh, I'm scrolling on my screen, but that's what was going on. So here's where we infer the JSON schema. So there were no surprises here, just those three fields. Most active users, so here I'm just doing, tell me who's the most active person rating. So this is probably my buddy who, just rates everyone, hoping someone's going to rate him back. Like, it screws with all the machine learning models. So, top 10 most rated people. So this is all like anonymous data. I actually got this data from someone that used to work over at eHarmony, and it's not any eHarmony data. It's some project he did, I think, back in. Actually, yeah, I can't remember where it's from, but yeah. So yeah, there's no names or anything, but it's actual data. Let's see anything else here. So here's the Parquet stuff. So I'm actually taking the same data that I just read in and I'm saving it out as Parquet. So this is where it's doing that inversion where it's got all the columns next to each other. And then any queries after that I'm doing are just way faster. This is 5.59 seconds for this. Just doing average, min, and max. This is off the Parquet table. And here's 4 seconds, which doesn't make any sense. So yeah, just ignore everything. Okay. It's faster with Parquet.
Why is the Parquet faster?
So yeah, actually, what I just realized is when you create the temp table, it's actually converting it into an in-memory columnar. So yeah, this right here takes the JSON and it's going to register it with the Hive columnar format. So we're basically comparing, and this is a small enough data set where it's storing it in memory. So that's actually why it's like a second faster, versus the Parquet, which is actually on disk. Oh, and yeah, so to answer your question, like the reason that these columnar formats are so fast is, right, because like I was saying, if you're gonna sum up everyone's, or do an average rating, like you want to go to the disk once and just read all those values. And there's tons of compression and stuff going on too, so it's small, and you could just add those up super quick. If you flip it and have like typical row column, then I have to go to that place on disk and then go back and then get that next rows, But if I flip it and have them all together, then yeah. Like check out Parquet. It's like there's a lot of like blog posts and stuff about it. So there's my attempt at logo for the website. Based on Tinder. Yeah, if you guys know Tinder, this is how I met my girlfriend actually. Yeah, that's not her. That's definitely not me. Yeah, I actually started this project before I met her, and I told her, she was like, "You're a goofball. Like, why are you doing this?" I creeped her out in the beginning. Yeah, that actually kind of looks like her down there with the curly hair. So yeah, the whole goal here, picture, these are logs, or this is in Dynamo, or this is in Cassandra. We're trying to match these up, right? So anything. So that would be me. I've rated her a 1. So it's like 0 to 1, basically. Tinder is it's just binary, right? Versus some of the other dating sites that are, 0 through 9, and no one has time for that anymore. We're all speed daters these days. So that would be, you either press no or, but reading hard is good. And that's what I heard from that. Yeah, this is all very relevant. Yeah, Valentine's Day coming up. You can share this with your significant others. Saturday, you can point them to the website. It's not an actual real website. I mean, it is, but there's nothing there. This is the data set. This guy was saying worked at eHarmony. I think I got permission to use it. I begged him because I started using it and built everything around it. So before I actually got permission. So ways to, the whole goal is to generate, matches, generate people that find other people interesting, right, or desirable. So, so here's a way to use PageRank. So I can take all those 0s and 1s, and like I said, this is my buddy over here who's just rating everyone, hoping someone's going to rate him back. Well, yeah, little does he know that PageRank is on his game, and his portion has been split up, versus someone like this guy who's like, that's the girl I want, like hell yeah. So he gets a full vote for her. And then there's things like shortest path, so this would come in handy if you're linked into Facebook and people are, obviously, like the closer you are in the social graph, the more intimate it would be. This is alternating least squares. Now, one thing I should mention is you're not going to see every single machine learning library built in Spark, and it's most likely because they're not very parallelizable. Alternating least squares is a very parallelizable and distributed type of algorithm. So, we get a lot of requests all the time. Hey, I want to do this, or this works in my case, but if it doesn't work on the Spark cluster, it's kind of pointless if it's just a single node. So here's something too. I'm just trying to give you guys some of these names. Like, I'll show a demo of alternating least squares, and I'll show PageRank, but there's some other cool libraries. This thing called DivSum to figure out similarities. K-means clustering. These are actually that's actually my profile, or was my profile. Things like country music, my cups out. So some of my interests. So what you would do is use TF-IDF. You would possibly use LDA topic, right, or like n-grams, and pull these things out and find people that are similar. So these are categorical. There's only 8 of these, and and a ton of those. So these are actually really easy to match up. But something like this, you have to pull out and figure out sonic hair is that's a keyword. Us Weekly. I sound horrible. This profile, I should update that. So just real quick, a couple types: supervised, unsupervised, machine learning algorithms. Anyone have any specific questions? I saw a lot of machine learning people out there. Anyone specific to Spark? I don't want to spend too much time, but supports classification, regression, of course recommendation. That's going to be some of the ALS stuff, and then finding clusters of people. Actually, Netflix did quite a bit of this. It was really interesting when you kind of just point K-means clustering at data and just see what it pulls out. Like, and I think there's a blog post on it, but they were able to find these crazy combinations of clusters, and people that watched on Saturday evenings only, but it was just like all these weird patterns that came out that we would have had no idea otherwise. So I should look it up. I'm pretty sure there's a good blog.
Do you use any of these recommenders in your Spark application?
Oh yeah.
Let's do it. So this is ALS here. Alternating least squares. What's going on, if you guys are familiar with matrix factorization, right? So you're given a huge sparse matrix, right? So this is kind of weird because typically you would do like user to product, like we're talking about Amazon, it would be like, this is me, and I wrote in a stapler and some books about whatever. But here it's this is the product, right? And these are the product. So these are going to be zeros and ones, very, very sparse. What we're trying to do is fill in the ones that we don't know. So what you do is you hold one of these rows fixed and calculate that, and you keep alternating back and forth. And you, at some point, have to converge. So that's what's called a hyperparameter for your model. And if you tell it to converge like super duper small, it's going to take a really long time. Probably isn't going to be very worthwhile, but so I can run this. Let me just kind of point out. So what we want to do, right, is figure out some of these missing ones so that you can recommend, right? So there's going to be like a value here this is 0.9, likely that this person is going to like that person based on all the surrounding data. So we'll just run it. The key here too is that you see, if you're given, so I had a data set, I think it was about 500 megs, I think, not that much data, but what you want to do is actually split it up, right, into training data. You do 70-80% training data that you actually know the answer to, then you hold out some data. So you train with one, then you test it with another set of data. So here we're training. These are the hyperparameters. These are just, these are specific to the different algorithms. It would be like convergence ratio, or convergence, which is 0.01. Get me? Yeah. So that's how PageRank works. Also, you can iterate and iterate and iterate, but if you don't give it some value to some threshold, it just going to keep on chugging. So this is a lot of data munging, going in and out of tuples, and but here's where we're actually testing. So I'm predicting based on known test data. So I held back data that I know the answer to, and this is how I'm going to evaluate my model. Here I'm just showing the lineage of a complex RDB. This is pretty crazy. Before I showed a simple one, but this is this is the output of the actual model itself. It's pretty crazy. So then you can evaluate it. We're going to use a couple techniques, mean absolute error. So basically tell me, which, how far off was I from the known data. You want this low, obviously, right? So, and then there's root mean squared error, just different ways to evaluate. You would choose an evaluation criteria. Typically, they're based on the size of the data, the type of algorithm that you have. There's different recommendations. I can't keep them all in my head. I always have to look them up. But I just want to show you guys different examples there. But, okay, and then I want to show GraphX. This is the PageRank. So here's my buddy there doing his thing. Do you guys know how PageRank works? Actually, this is kind of a good question. Where does the name Page come from? Yes, I didn't know that. I thought it was a web page. This is why I had to move to San Francisco. So I didn't know that stuff. So someone owns a shirt. You can take my shirt. It's not Databricks shirt. And they shouldn't be wearing it. Okay, so the way PageRank works is you're basically given one, token, $1. You can think of it kind of in the same way, and the more people that you start to dish things out to, the less your dollar means, right? So this guy, each of his his picks only counts towards 0.2. This guy's really somewhat selective. He's 0.5. This guy down at the bottom is super selective, and he found the girl he wants, and he is hoping she's going to take him back, but she gave him all. And so this continues to iterate. And so, there's some other munging going on. I think multiply by 0.85 or something, and then from here, whatever. So this is a good one because now this person can only give a portion of what she's been given, kind of thing. So basically, kind of rises to the top. Here I call it the most desirable. But in the Google sense, it would be kind of the most relevant pages, right? And here it's most desirable. So let's see the results. I think I'm joining with their actual names.
Are you running this on your laptop or on the cloud?
This is cloud on 6-node cluster. I can show you guys the UI too in a sec. So, the most desirable here is my girlfriend, Kimberly. Wow, that was a surprise. And the second most valuable, most desirable is, of course, me. So, this is my data. I had to fudge that after I met her because it was actually my ex-girlfriend from high school. My first girlfriend from high school was #1. And she was not very good. It is the first name that came in my mind. Yeah, so I can show you guys. So this is kind of the jobs view here. This is us running the mean squared error. That was one of the final steps. It shows you how many tasks. Actually, this is kind of cool. This is fairly new, but it shows you a stack, kind of a stack trace. This doesn't mean an error. This just means if you want to, trace through and see what was actually being executed at that time. Here you can see, things like, so yeah, these are the actual nodes that were involved. So I guess it's just, I think it's 4 plus the driver. That thing that was on the left, that's its own node, and then it has 4 other worker nodes. Shows you how much shuffling is going on. Obviously, they want to minimize that. Gives you some stuff about scheduler delay. This is, how long did it take me to find a node? So if that starts to get high, then you're obviously running into resource contention. Maybe there's too many people that are out there pulling, and either have to increase your cluster or go make the power cord out of there.
Is this one the public?
The tool.
So Databricks Cloud.
We're doing, I'm not the sales guy, so I shouldn't be saying too much, but Strata, I think it's going to be a little bit more open than it is today. Right now it's still beta, and so we're kind of fleshing things out. And that drove me nuts, but I realize now just how many support cases we have, and how many things that we're fleshing out with this beta. Actually, I always hated beta programs, but it actually makes sense. But yeah, so Strata, just keep an eye out. There should be a developer trial kind of thing happening. So if you guys want to check out too, there's a project called Spark-Notebook. It's based on iScala notebook, and you can point at, there's a guy, Andy Petrella, I think, out of Belgium, who built it. I think he has a consulting company. Yeah, he's basically built this tool. I mean, it's not as full featured and stuff, I have to say that, but it's not bad. And you point it to your local cluster. Of course, the main advantage of something like Databricks Cloud is that you don't have to manage the cluster yourself and that stuff. And it all hooks into Amazon pretty easily at just a couple clicks and you get it going. But, let me show, I think we have I need a couple minutes. Because I want to show streaming, or at least talk about it.
What's the ballpark cost on those 6 nodes to run that?
Yeah, we use R3 2XLs. That's a good question, because they just lowered it, I believe, in November for reInvent. I don't know. This is, I should probably know this, because I'm running 4 clusters right now. But, I got spoiled at Netflix, we would have 1,000-node test clusters, and then we decided to split the company, and then all of a sudden I'm working on a cost savings project. So that was 3 months after I joined. You guys remember that? It was hard walking around those goggles. I had to turn my shirt inside out. And couldn't bring my bag. Okay. So these were the 2 demos I just showed. Just real quick, Spark streaming, video streaming, that's not what we're talking about. Hadoop streaming is actually piping, when you want to go from one language to another. That term always confused me when I first was getting into Hadoop. We're talking about big data streaming here, so this is Spark streaming, Kafka, and Storm. Everyone asks us what's the difference between streaming, Spark streaming and Storm. Tons and tons of data on it, or research on it. People have their strong opinions. The top ones for Spark streaming are it's a single API that's shared by everything, versus Storm. You have to kind of bounce in and out of different language constructs, and then also Spark streaming is a mini, I guess it's a micro batch, versus Storm, which is sort of each record at a time. So Storm is going to be lower latency because you know that one record is going to get through the pipeline quicker versus batching with Spark streaming, right? Because basically what Spark streaming is doing is it's creating little batch jobs. They're totally optimized and it's super, there's things hanging around waiting for these jobs to come in, but that's basically what it's doing. It's taking batches of those RDBs and processing them, and then so that's kind of where, yeah, so we have support for Flume and Kafka. Kafka's huge. We're seeing this a lot. Like Netflix is using them. Yeah, do you guys know Jay Krebs? Have you guys heard that name? He's the guy behind, he was from LinkedIn, basically developed Kafka. He just went off and started a company, I think Confluent, which I was.
I love logs.
Yeah, exactly. Yeah, I heart logs guy. Yeah, I always call that company Confluence, and everyone always yells at me. It's Confluent with you. There's a lot of work going on in Spark streaming. I felt the pain of this when I built Kinesis. There's a lot of, at the time, there wasn't a write-ahead log. So, like with Cassandra, data comes in, it gets written in, the append-only log, and then if a node crashes, it'll merge everything, keep things. It'll play back, basically like your Oracle, transaction logs. That's the concept. So this is just some examples of Lambda Architecture and using streaming, and I'm not going to spend too much time here, but sort of capturing that whole thing about building models online every minute. So yeah, dstream, this is to streaming what an RDB is to core Spark. So dstream is basically micro batches of RDBs. And you can pretty much, this is a goofy diagram, but you've got the input stream, so this is actual records coming off the Kinesis queue or stream or a Kafka queue, and every time interval. So right now it's just time intervals. There's no way to do like a number of records. I think there's some work being done there, but every 5 seconds it'll batch up all of these things, and then so yeah, now you have a set of RDBs that you can call the same. You can call map and filter on these dstreams. You can call join, so you can actually join separate streams coming in from different sources. So I mentioned the write-ahead log. There's also checkpointing support, to try to minimize the data loss, and, data duplication, that kind of thing. So yeah, again, here's join and union and filter and map and flat map and all the fun stuff that you saw with RDBs. Yeah, there's reduce. I keep forgetting reduce. That's probably like the most important one. Also, too, you can maintain state. So this is good for counters, things like that. If you want to keep updating like a high water mark, that kind of thing. So yeah, just like there's transformations and actions within the RDBs, it's the same thing with dstreams. These are the window and state operations. You can have like windowing functions. You can have a sliding window, have state maintained across the sliding windows, that kind of stuff. Also, dstreams participate in the whole lineage concept. So if you have nodes that are processing dstreams, and that node goes down, it's processing a partition of all that data that has come in the last 5 seconds. That gets spread out to the cluster just like a regular Spark job would. It can actually go back to the input source. So with Kinesis, for example, or Kafka, you basically ask it to replay as a particular checkpoint. And then it goes through the exact thing, same process, but just for a partition. So yeah, that's a good thing too about Kinesis and like Kafka is that they're partitioned sources. So you can actually, in parallel, be pulling from these things, right? So with something like Flume, it's basically point to point. You're just sending data, but you want to use partitions for scalability, high throughput. Cluster deployment. Essentially, what you do is pull a worker node or add a worker node, and that guy has the actual streaming receiver. So the Kinesis work I did, that's exactly where I was playing with right there. This would be the producer of the source. So this would be Kinesis, that'd be the Kafka cluster. Participates in the cluster. So basically data comes in this way, the streaming receiver receives it, actually replicates it out. I'm not showing that here, but it's going to replicate it. It's going to write to the wall, that kind of thing. And then it's going to ask it's basically going to create a job and then submit a job. Adding workers. Won't spend too much time on this. Yeah, even though it was like 2 months away. Yeah, you can look up the Kinesis limitations and pricing. We're seeing a lot of people, I shouldn't say this on camera, but we see a lot of people like going Kafka just because of the pricing model. I don't know, the customers that we've talked to, they price it out and it just doesn't make sense. It's always hard to kind of balance the managed service with, yeah, I can run my own Kafka cluster, right? But
Yeah, but you buy it from where that, what one?
Yeah.
You're in AWS, so you're paying for EC2.
Yeah.
okay. Kinesis best practices, we'll skip that. At least once, at most once. Ordering, obviously important. But one thing about, yeah, this is kind of interesting, is that it's difficult to maintain total order across your partitions, right? So when you have a streaming source that you've got receivers pulling from different partitions, if you're going to expect global ordering, you're going to lose your scalability, right? So with Kinesis and Kafka, you're guaranteed order only within a partition. So if you're expecting, so yeah, you have to consider that when you're defining partitions. That's the big bullet point out of that. Checkpointing. Yeah, this is kind of interesting. So just like I said, with streaming, you're creating little mini batches, or yeah, batch jobs. So yes, everything from this point on is just as if I was, in my REPL submitting jobs, or Databricks Cloud submitting jobs. So if this worker goes down, it's just one blip, and everything keeps on chugging. And then this guy's going to go back and ask this guy, and eventually, make it back to there, or pull it from that second replica that I mentioned. This is a streaming web UI. So these are the two receivers. The example that I actually have two shards from my Kinesis stream, which are basically partitions. And each one is pulling from a different partition. So these are long-running Spark jobs. You'll see this number will never increase. It'll always be 0 or 2 because it's got two guys going, and nothing from this view, nothing looks like it's completing, but it's actually just a long-running job. And then these are the actual micro batch jobs that it's submitted. So you're probably wondering, if you have these small, 5-second intervals, 5-second sets of data, and the actual job is doing some filtering, doing some processing, and then storing that in HDFS. It sort of reminds you of the small file HDFS problem, right? So what we see a lot of people doing is having kind of background jobs that are merging these small files. HDFS doesn't work small files. Tuning. Yes, I want to leave time for questions too. So, approximations. Yeah, this is kind of interesting. The approximate is the new exact. I sort of talked about this in the beginning. And this is something that I experienced personally. I was on the streaming team at Netflix, and there were times when, our whole data pipeline, our log pipeline from our streaming servers was about 2 hours, right? So if there was something going on, it would take me 40 minutes to run the Hive query, and then, which would give me the exact number. It was 2 hours out of date, or 2 hours and 40 minutes out of date, whatever. I didn't want exact numbers. I just wanted to know what was the top 5 errors that were happening. Typically we didn't know if it was from iOS or if it was the PS3 or whatever. So we were always running multiple Hive jobs. We're all, it'd be all of us kind of pouncing on the same cluster, trying to find different data. Yeah, with something like this, with an approximate, there's this product or this project called LinkDB, which actually is Presto. If you guys have heard of Presto out of Facebook, the same guy actually works at Databricks now. He did his internship at Facebook, developed Presto, and then pulled it into our site called LinkDB. You can get like a time bound. You can say, yeah, I want this answer within 5 seconds. I want it within particular error bars. I saw this presentation recently by like Michael Jordan, not the basketball player. I think that's why I was interested in him, because I'm from Chicago, and I was like, yeah, who is this guy? Why is he talking about big data science? But yeah, his whole thing is like never think of queries as being exact anymore. Like just like always think about error bars. Because, I mean, why do you need exact? Well, I guess banks need exact, but that's why I don't work at banks. So yeah, things like hyperlog, count-min sketch, bloom filters, these are all over the code base. Okay, 5 minutes, okay. Count-min sketch. Yeah, so there's these methods on RDB called sample. Yeah, it's doing some sampling there. This is LinkDB I was just talking about. Hyperlog is actually this method on PairRDB. PairRDB is when you have, if you're going to be joining something, you have to create a pair, so a key value. Count-min sketch is used. There's an example of the Spark Stream code base, using Twitter's algebra. Bloom filters are everywhere. Cassandra uses them. Yeah, and there's the statistics library that came out of the MLlib project that is now like a first-class citizen, can be used outside of MLlib. They basically pulled it out into public for us to use. There's some Spark conferences coming up. Strata's next week. Yeah, anyone going? All right. Yeah, come find me. I think I have to work with you. Yeah, we're also doing training there. We're doing a 3-day training class during the conference. I have no idea who or why anyone would sign up for it, but it's sold out like super quick, so I guess someone was interested. But so yeah, I'll be bouncing between the training and food stuff or whatever. But we've got Spark Summit East coming up right after. That's in New York. First time we're doing it outside of San Francisco, and then back in San Francisco as quickly as we can in June. I spent 37 years in the cold in Chicago, so I can say it blows. Let's see. Yeah, how about Q&A? Yes.
So Python supports. So I've been working with Spark, like 25% of the time for the last 4 weeks, brand new to it. But I've been working mostly with the Python stuff.
So here's Spark, summarizing, working with the Python stuff, working mainly on the ML stuff. So it's well documented that the Python does not have the same support for like the the performance metrics on the algorithms, right? The Scala stuff will give you a lot more information about the results of your
like the evaluation criteria.
Yeah. And that's not available. That's okay. That's documented. I knew I was going to get that. But I just get all kinds of weird stuff, like out-of-memory errors, no matter how much memory I give the worker or the client or any part of it, and really weird things when it's not connected to a TTY. So if I run it with no up or screen, it dies, where it doesn't if I run it in my shell watching it.
Yeah. I don't. Yeah.
I hope I'm remembering the latest release. Is there stuff in beta?
The only thing, the only thing I can think of off the top of my head is, Python is basically bridging out to the JVM, right? Using Py4j and like serialization stuff with Python it's a little hokey. I know at like Databricks, within Databricks Cloud, our beta customers, we can see issues with Python. We keep trying to work through them one by one, but yeah, why don't you hit me up with some questions? Like, actually, we can talk after.
Well, the good news is I have tried converting some of it to Scala. It's really tricky to convert Python code.
Yeah, man, just do it and go.
I don't know if this is a full-fledged question, but you had this cool display function that you were using for your RDBs. Is that part of the Databricks notebook
BLE on the cluster?
No, that's Spark.
Yeah, that's a Spark thing. Yeah. So you're talking about the to debug string where it shows.
No, there was a display function. Just display. The word, the function was called display.
Sorry.
It's in your SQL demonstration.
Yes, which is on the screen, but not the screen. That is that's a Databricks thing.
Is that going to be
But
everybody think at some point?
Yeah, I get myself in trouble when I talk about feature stuff, but I can say if you sign up and people have asked for it. This actually just came up recently. Someone had their own. Right now that code is private, which I talked to the engineer and we don't know why it's private, but yeah, it's actually been causing us some issues because it's a cool feature. I mean, basically all it's doing is just converting rows into just doing row column and just displaying it. So.
It looks slick.
We built we had one of our more like aggressive and like tech savvy or Scala savvy like customers actually used reflection and built because you can see what it's doing when you run it, you see the error, but yeah, it's not accessible.
I guess the thing that I thought was cool about it is it worked differently for different RDBs.
Yeah.
That's
Exactly. We basically have adapters and we recognize it. And so, this particular customer had their, they basically built their adapter.
Two quick questions. BlinkDB, is it integrated with Spark? And my second question is, forgot the second question.
Is BlinkDB, it is experimental. We had a hack day recently, and the guy I was saying, that was the intern over at Facebook, he basically integrated it with Databricks Cloud. We're all trying to get our stuff working in here. It's a fun environment. But, it is, as far as I know, last I checked, still experimental. The problem is I always confuse like what's in Databricks Cloud versus what's in, but yeah, so developer alpha. I mean, it works. It's cool, yeah.
Cool, and I remember my second question, Spark SQL. So it seems like it's missing quite a few things. Like I was trying to do filter based on timestamps. That seems like it's still missing. So just a question, like, is that like under heavy development right now?
Filtering by timestamp, do you mean like partitioning by? Because you can create partitions by timestamp.
This is SQL query that was doing a where clause on timestamps, and the Spark SQL was not understanding, was not able to parse timestamps. That's the timestamp bug I think that I mentioned earlier. Yeah, what we're telling people to do right now, it's a total bug, and it's like top on the list. Yeah, but like Spark 1.3 is I think just got cut, and that's going to get rolled into our it's big. Yeah. So we've been telling people just convert it to Unix timestamp. That way.
I have a two-part final question. Like, what do you recommend to start with, like to get up to speed, and two, until your books are done? What do you recommend on the forefront?
Yeah, well, I mean, learning Spark is going to be in print. I think it's going to be at Strava. Actually, that was the kind of final goal. I've been reviewing it the whole time and reading it. It's awesome. It's like the reference. So, also there's Spark certification. Yeah, you guys heard about this. The O'Reilly people, there's an online thing that I can't seem to get to work, so I'm not even certified. I have no idea what it's like. But there's some kind of webcam thing, that I have to keep an eye on you to make sure you're not asking your mom or something like that. I think they actually they keep an eye on your street. Anyway, at Strata they're going to have like a booth where you can go sign up. It's a couple $100 or whatever. Yeah, I mean, Learning Spark is really good. Also, if you search the AMP Lab, I think it's called AMP Camp, which I think has been renamed to Spark Camp. They have great tutorials, and it's got the solutions that are hidden until you actually want to see the solution, or you can just go look at the solution like I do, and you can go back to everything. Yeah, I mean, basically covers everything.
Hey Chris, what's your opinion on Spark Job Server? And how does it relate with using Yarn on Mesos?
Spark
Job Server? Yeah, it's been Job server.
Oh, the job. Oh, the yeah. Yeah, was I talking to you about this? Did you want to talk about this already? Yeah, that's the Uyala project, right? Where you can basically share context across. Yeah, you know, it's. I ask these guys like probably once every couple months. The Databricks guys like, why we don't just roll that in? I know that we're doing a lot of like the way Databricks Cloud does it. We basically use like scheduler pools. I mentioned the fair scheduler pool. So each notebook, this is called a notebook, has its own scheduler pool. So that's separating it out. And then we do a lot of replicable tricks and things like that to keep things isolated, right? Make sure people can't tamper with each other's context. It's awesome. I mean, and I think, is it Evan Chan that spearheaded that over? I think he left and actually pulled it out of the Uyala GitHub, and now it's its own project.
Yeah, yes. I mean, would you recommend running that type of Mesos or standalone? What would your opinion?
Yeah, I mean, we for Databricks Cloud actually use a modified version of standalone. Yeah, I thought for sure we'd use Mesos coming into it because it was developed by the same amp lab, but it's been powering us pretty well. Yeah, I know a lot of production deployments. It basically comes down to if you need Kerberos integration, you have to go Yarn. Mesos has fine-grained mode and coarse-grained mode, which I just had lunch with one of the Mesos developers, and I'm like, why do you guys call it that? It doesn't make any sense, right? But yeah, I'm getting slammed over here on Twitter. So yeah, fine-grained mode would be if you want to start up a new JVM every single time, or coarse-grained mode would be it's running all the time and it's just picking up tasks and stuff. So it just depends on the flexibility. And of course, the hybrid. If you already have a huge Hive installation, Hive or Pig installation, you want to co-locate these things, right? Like they all want to be. So then you want to use Mesos or Yarn. But if you're starting fresh and you stick with Spark, just use standalone. There's no reason not to.
I actually had a question about the job server as well. What do you recommend? So let's say you create a recommendation engine and you want to now serve the data out to a website.
Yeah.
Would it make sense to use that, or what's the best path?
Yeah, I mean, that's how I've seen it done. I keep an eye on the Spark user list, and I mean, short of creating your own, web app and like serving it that way, but yeah, you're right. Do you guys know of other projects that even come close to that, or is everyone just using job server? Yeah, honestly, yes. I haven't thought about it too much, but let's see what I read on there. That seems to be the most full featured.
Hi, so questions about Spark streaming. So you have a slide that you have a worker node that is setting incoming data stream, and then you have other worker nodes that are processing the data stream, right? And you mentioned that one of the worker nodes to go down and then the job get replicated. But what if the node that is hosting that those two secrets are down?
Yeah, this guy, right?
Yeah.
So I think I have a slide on it, but I kind of blew past the fault tolerance stuff. You have to, the point at which this guy goes down. So first of all, the write-ahead log, right? That's going to take all the data each time. It's not going to act back to the source that it's gotten the data until it actually writes it to the wall, right? That process will just stop pulling. Yeah, so this is why, I think a lot about Kinesis and Kafka because they're partitions, they're replayable, they're reliable, I can act, I can checkpoint, and it's a pull model. If you start getting into Flume and things that are kind of pushing data, like my head just goes, like I don't even know what to do with that. I think they've been putting a lot of work around Flume. I know that some Flume enhance. I think there's Flume transactions or something just got pushed in, or support for that just got pushed in. I believe Spark 1.2 or maybe Spark 1.3, but that process will stop receiving, and with the new write-ahead log, no data should get lost, right? When that process comes back up, if you use Supervised or whatever, right? It's gonna like recognize that there's data in the write-ahead log that has been received but not processed, and then it's just going to pick up from there. Yeah.
So manual intervention to restart the receiver.
Yeah. Well.
And it applies to all kinds of receivers like Kafka.
Yeah, I mean, picture like there's going to be a ton of these, right? Like I'm just showing one, but if you have like 20 partitions or 20 shards, there's going to be 19 of them still chugging along. It's just that one. There's going to be that kind of lift here.
Restart actually your cluster manager, whether it's Yarn, Mesos, or Spark standalone, will bring it back up.
Oh yeah, right. Yeah, this is being managed just like every other. I mean, this is this is Yarn. This is standalone. You recognize that this guy's missing, and it's been. Yeah, I was thinking more of the actual process on that node. But, yeah. Okay, we got 2 more questions.
Yeah, just a quick question of interest on the Spark notebook. When you set that up and you connect to your cluster, what kind of resource reservations are there? Is it, I know with the IPython, you can actually, in some implementation, some cluster, tie up a lot of resources. Just sitting there connected with your notebook open.
Yeah. So like you're getting at the fact that, okay, and this is actually one more reason to use Mesos over Yarn, is that Mesos will actually let you dynamically allocate, it'll recognize something. So what you're talking about is if you launch a REPL, so not just a notebook, but if you're actually in the Spark REPL, that's an actual Spark application, right? Like, that thing's taking up resources. And I think what your question is, if you go to lunch or like go home for the evening, it's still holding on to those resources, right? So if you have 10 like data analysts during the day or data engineers during the day that are just sitting around getting coffee or whatever, they can fill up the whole cluster. Yeah, don't do that. I mean, basically, either use something like Mesos where it'll actually quiesce. Is that the right term?
Yes.
Yeah, quiesce. Those resources will actually allocate it dynamically to other things that are active. Now, the downside of that is when you come back in from your coffee break and start typing, it's not going to do anything until it can get more resources, get the old resources, not the old ones, but get resources again. Right. So, did that answer your question?
It does. It's, I'm going to be a little cautious before I be able to say.
Yeah, well, so you can, so I kind of touched on this before, but you have job stages. These scheduler pools, so what you could do is basically isolate and say, these are all the REPL guys. Yeah, I think that was the thing. So each notebook, I've got 6 or 7 tabs up here. That's a separate, but this is like implementation detail for Databricks Cloud. That was one of the first questions I asked: is how the hell do you guys do this? How do you have, how do you keep different notebooks and this basically keeping one from doing all the resources. So that's how they do it. Yeah, they're each given equal weights and there's FIFO within there. So that's how they do it. Yeah, this guy's been looking at me all.
Oh, sorry, no, that was good. That was a cool presentation. No, I was going to say that the Spark Summit actually puts up all the training videos every year. So like if you want to learn, like you can just look up like Spark Summit training, and you can look at all the slides and all the videos for like the actual like training sessions that they have at the summit. So it's also really good to like go through stuff.
Yeah, actually, it's funny because I bought a ticket last year and I didn't end up going because there were so many sessions I wanted to see at the same time that I actually sat home. This is like the nerdy, I can't believe I'm telling people about this, but I had 3 separate windows and I would literally just bounce, because it's all live streamed too, so all the training materials. I know there's, like, do you guys know Paco Nathan? Have you heard that name? He's kind of Paco's a big guy. Oh yeah, was he? Okay, cool. Yeah, Paco's a cool guy.
Also, edX has a class starting on Scala, on Spark, February 23rd.
It's actually posted.
Oh, what April? That's right.
Is that the MOOC that you're talking about?
Yeah.
Or-
Yeah, and it's supposed to do a spark.
Yeah, yeah, that's
They
it.
pushed it back to April.
Oh, they did?
Yeah, there was a machine learning.
Yeah.
That got pushed back.
Really? Oh, okay. Yeah, I didn't know that. I was all excited about that too. Yeah, so if you guys don't want to pay for the summit, or if you don't want to fly, I don't want to fly anywhere, but you can do a little triple cam or whatever. Okay, questions? I thought about these for like 2.2 seconds, so I apologize if they're wrong. I guess the first question, what's the core abstraction for all of
All right.
Explain what's an RDD.
Yeah. Yeah, can you explain it?
It's an interface. It's an interface. It's an interface.
It's an, yeah. Physically, it's an interface.
Kimberly.
Dryad.
No.
Dryad. Who said Dryad? Oh, wait, I'm showing you the question. What is the name of the SoCal-based company that Spark After Dark is based on?
Tinder.
I don't know who that was. Okay.
Okay, we got t-shirts. What's
Size.
medium, small, a couple of mediums.
What are the two types of operations in Spark? I kept in the transformation. Yeah, so there's two types of operations. It took me a while to get these terms straight in my head, and actually I think streaming, the guy that wrote streaming was using different terms, so when I first day I'm like, you gotta synchronize these terms, like I'm totally confused. Yeah, there's transformations, which are lazy, and there's actions, which trigger transformations. That guy in the, is that pinstripe? Oh, yeah.
Medium or small? Is it well?
It's a ball of that
I think it all R2.
Name one probabilistic, we didn't really talk about this too much, probabilistic data structure or algorithm. Yeah, you're a little too close, I think. The speed of sound is in your advantage over here. So we're going to penalize you. That guy, where do you go? Yeah, right there.
Medium or small?
Medium.
What would you use hyperlog log for?
9%.
Or presence in the set, right? Yeah, cardinality, which one? I think that's, yeah, hyperlog log will tell you if something is in the set in a very efficient way. Basically hashes and then, puts, but it can produce false positives. So you can at least narrow down the fact that it's in that set, but it might not actually be in that set, so you can narrow it down. Okay. What is the best and sweetest? Okay. Everyone gets a shirt.
It's
Right.
not margarine.
It's not margarine.
I've never thought about that.
I mean, it's not butter.
Yeah.
Maybe what's small?
The biggest guy is small. All right, I think that's it. Thank you. That's great to hear.
Thank you.
I want to go to
Oh, I hate it when it's all this air, like even not some solutions like yeah. People have already gone through it and really understand
Not still.
Yeah. It's like coming up with parts. Sure.
Yeah.
Especially since there's like a summary, like they already gave like about different stuff. It's like you already kind of know.
Yeah.
So yeah. I just think like it's possible.
Yeah.
I've noticed in the video it's like solve problems. Like personally, I'm solving problems, to you, like the problem solver, this person themselves who like trying to figure it out. But globally, it's just like someone is it's like really challenging.
It's not like a really many people with a lot of bias. I mean, I guess that.
Okay, Subhash, thank you.
Thanks.
Once I got a bunch of stuff together,
sorry.
I'm going to give a talk.
Class. I haven't actually class.